So far, we've talked about types of scenarios where we have one thing happening, like the probability of flipping a coin, or flipping three coins consecutive, or rolling a die and flipping a coin. And sometimes these events are related, and sometimes they're not. That's what we're going to talk about right now. We're going to talk about compound events. And so let's consider I've got two boxes of marbles, box X and box Y. And what I'm going to do here is I want to figure out the probability of getting a blue marble from X, so one of these, and a red marble from Y. If I were to draw a random marble from both of these boxes, what's the probability that that the one from this box would be blue and the one from this box would be red? So, I encourage you to pause it and think about it. About what do you think that would be? Do you think it's greater than 50-50? Is it less than 50-50? Take a moment and think about it. Let's talk about how we would arrive at this answer. Here is my sample space described by a grid, or illustrated by a 2D grid, of all the possible outcomes. Here's my box X, blue, blue, green, green. Here's my box Y, red, 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 white. And here are all of the shaded outcomes where I have drawn both a blue from X and a red from Y. So this is a total of 6 out of the possible 16 outcomes, which reduces down to a 3/8 chance. I think this is kind of interesting. 3/8 is less than 50-50, right? 3/8 is less than 1/2. Yet, if I were to count all the marbles that I'm interested in, blue marbles and red marbles, there are 5 of them out of the total 8. So I think that's kind of interesting that there are more than half of these marbles that I'm interested in, yet the probability of drawing both of these is actually less than half. Now, drawing this two-dimensional grid, counting all the outcomes, and then finding the favorable outcomes seems like a lot of work, and you're thinking, there must be a better way. You're in luck, because there is. Just like this guy, who doesn't have a cup, I guess? Who knows what his problem is? But just like this man who needs a better way to drink his water, I'm going to give you a better way to come up with these compound event probabilities. So first off, let's talk about the concept of independent events. Basically what that means is that events are independent if the occurrence of either of them does not affect the probability of the other. So if you think about from the last example, we had 2 separate boxes and we were drawing from each of them. Whatever I draw from this box X has no impact on what I draw from box Y. That's what I mean by independent events. They're not related at all to each other. They don't affect each other. We say that the probability of blue from X and red from Y, we said that came out to be 6 out of 16, or 3/8. Well, let's think about separating those independent events. What is the probability of drawing blue from X, and what is the probability of drawing red from Y? So blue from X is 2 out of 4, since there's 2 marbles that are blue, and then red from Y is 3 out of 4, since there are 3 marbles that are red. Maybe you're seeing that if I were to actually multiply these things together, 2/4 times 3/4, that's where that 6/16 comes from, which is at 3/8. So it turns out that if I multiply those independent events together, the probability of them happening independently of one another, and multiply those probabilities, I end up getting the probability of both of them occurring. So the probability of A and B is equal to the probability of A times the probability of B. Notice that this is and, not or. I need both of these things to happen. And this is also, we can extend this further to multiple independent events. If I've got 3 independent events, I can multiply the individual probabilities together, 4 independent events, etc., etc. So I can just multiply all these things together to get the probability that all of them will occur. So let's talk about an example of this. Here I have a coin and a die tossed simultaneously. I want to determine the probability of getting a head flipped and a 3 rolled. And I'm not going to use the grid. So basically what I'm going to do here is I want to find the probability of a head and a 3. And that's going to equal the probability of flipping a head times the probability of rolling a 3. So we know that the probability of flipping a head is 1 out of 2. And the probability of rolling a 3 on a 6-sided die is 1 out of 6. So when I multiply these 2 probabilities together, the probability of getting both of these things is 1 out of 12. Just like that. So why don't you try an example for yourself. Here we have a couple with children, and there's this whole happiness and unhappiness going on here. You want to make these people happy. So pause the video, read the question, give this one a shot, see how it goes. All right, and here are my solutions for this example. One thing I just want to point out is that after I spent all that work finding the probability of being happy, which unfortunately is pretty difficult in this case, so maybe they need to change their expectations. Once I found that probability, to find the probability of unhappiness, I could just subtract 1 from the probability of happiness. You might recall that we call these two events that are linked, we call them complementary events, because they oppose each other, and when you add them up together, you do get 1.